This video walks you through how to use Beyond Labs for lab number 8. Please make sure you watch the theory for the proton NMR together with its notes in there. Proton NMR and IR, these are the last chapter in organic. So we're going to hit back on these topics in the course. Once you do this, you can go ahead and access the Beyond Labs assignment. For this lab number 8, you also have a top hat and owl assignment as well. So for the Beyond Labs, you do have two worksheets that you would need to do. As we said, it's the same thing as in the FTIR. These are integrated through ecampus, so you don't need to go into Beyond Labs or anything like this. Just go ahead into the worksheet. I'll show you how to work with one worksheet, and it's gonna be the same for the other. Same thing for the other. And then use the sheet that I gave you for the nomenclature in order to name those two esters. Whenever you want to name an ester, so this is the RC double bond O and then OR prime, always start by naming the group that is connected to the oxygen first. So if you have something like this is a carbonyl, an O, and a CH3, you start naming the group that is connected to the oxygen first. So this is going to be methyl. And then starting from the carbonyl, this is going to be 1, this is going to be 2, this is going to be 3. Choose the longest carbon chain that contains the carbonyl. And this is going to be propyl. So it's going to be prop. You're going to name it as the derivatives of carboxylic acid. So this is going to be, if you want to name it as a carboxylic acid, propanoic acid. So you're going to do here is you are going to drop the ic acid and add ATE at the end. So it's going to be methyl propanoate. So whenever you want to search for Beyond Labs, that's going to be methyl propanoate in its proton NMR spectra. Let's have another example here. If you have a benzene, and on the benzene there is a carbon and there is a carbonyl. This is one of the structures that you have in the in your worksheets in there. So you start by naming the ethyl group first. So that is going to be an ethyl. And then go ahead and number the longest carbon chain starting from the carbonyl. So the longest carbon chain here, it's going to be an ethyl group. Okay, so this is going to be ethanoic acid. So we're going to drop the ic acid and it's going to be ethanoate. And on the second carbon, there is a benzene. So you can do ethyl to phenyl, ethanoate. Now, because it is two carbons in there, and on the first carbon, definitely there is the ether part of the ester. On the second carbon, definitely there is the phenyl group. So we can drop the 2 over here. So you don't have even to mention the 2. And you're not going to see it in Beyond Labs mentioning the 2. So the name is going to be ethyl phenyl ethanoate. Also, they run by the common name. Instead of writing it as ethanoate, they write it as acetate. So it's going to be ethyl phenyl acetate. An acid group is a simple group that is made up of a CH3 and a carbonyl. This is called an acid group. And here we are calling it an acid group because you do have two carbons. You do have the carbonyl, which is, this is the carbonyl, and then on the acid you have a phenyl group. So this is the acidic carbon, which is the CH3. On it there is a phenyl, and this is why they call that an acetate. This is a common name, this is the IUPAC name. I believe in Beyond Labs they are writing it as a common rather than the IUPAC, like this. So back to this sheet over here, you're gonna name those compounds. For example, this one, this is going to be an ethyl, this is a benzyl, so it's going to be an ethyl benzoate. This is how it's going to appear in Beyond Labs proton NMR sheet. So if you look at the ethyl benzoate, you're going to see a table that you're going to write the chemical shifts for each of the different signals, proton signals, the multiplicity, and this is the integration. So this hydrogen with a dagger in there, this you're going to specify the number of hydrogens that result for every peak. I'm going to show you how to do this, and this is the integration. It's directly from the proton NMR spectra from Beyond labz in there. So in order to figure out the multiplicity, you can access the Beyond labz from the worksheet, access the proton NMR, and look for the name for the structure that you are working with. So for the first one, we're doing the ethyl benzoate. I believe that the ester is all the way down in this area here. So we're looking for ethyl benzoate. They run by alphabetical order, so this is the ester over here, so we're close. And this is the ethyl benzoate. Just make sure that the name is exactly the same as the structure that is written on the board here, and it matches the one that you have in your worksheet. Make sure that you are on the proton spectra, and go ahead and press on the integration and on the proton NMR spectra in there. You guys, just let me tell you here that every time you access the same molecule, you're gonna end up getting different areas in there. So if you want to do the integration, go ahead and do the integration. Don't go in and out, because every single time you're going to generate different peak areas. Now these peak areas are going to correspond to the number of signals that you have. So count the number of signals, of course, neglecting the 0, because this is the reference, the TMS reference. So here I do have 5 peaks. The 1, 2, 3, 4, these are the number of peaks, and this is how they are numbering them. So stick to the way that they are numbering them, so that I can follow up when I'm grading your worksheet and your saved lab workbook. So peak number 1 has an area of 112.93, peak number 2 has a 58.08, so forth in there. Now I can easily see from the intensity of the peak, I know that the first signal is gonna be a CH3, and I know my structure that it is an ethyl group. So let's go ahead and write it down over here. So I do have an ethyl group. I do have a CH3. So I have a CH3 here, and I have a CH2 over there. So I am expecting this one to be further upfield. So I'm expecting this CH3 to be this signal here. And it is a triplet. If you go ahead and zoom, that is going to be a triplet. So you can zoom like that, and then you can zoom out. This is how you read the multiplicity. Back to the integration there. So to do the integration, you're gonna go ahead and add all the areas. Add the all areas, so add all of these values in there. Let's say the sum of these areas is y. Okay. Now I know that here I have 10 hydrogens. Go ahead and figure out your molecular formula for the structure, and this is going to be 6, 7, 8, 9, C9, and this is H10, and it's an O2. So I know that I have a total of 10 hydrogens in there. So go ahead and take y and divide it by the number of hydrogens. It's exactly as I did in the video when I was explaining the proton NMR. And let's say if you get a number m, then you're gonna take each one of these peak areas, and you're gonna divide it by m. So you're gonna take 112.93, you're gonna divide it by m, and you're gonna get a number. That number, you're gonna round it to the nearest whole number, and it's gonna correspond to the number of hydrogens for that particular peak. So you're gonna see here from the way that I say it, since I do have proton A in here, this is proton A, this is proton A prime, this is proton B, and proton B prime, and the proton C. I know that benzene here has three different types of hydrogens: proton A, proton B, and the proton C. And these are the three different types of hydrogens between 7.5 and 8 parts per million. So proton A is going to be the furthest downfield because it's the closest to the carbonyl. So I am expecting that number 1, which is peak number 1, to be proton number A. Please keep the same numbering in there. And then now proton B corresponds to 2 hydrogens in there, and it's the same intensity as proton A, which is 1. So I'm expecting that this is going to be signal number 3. And then proton C, it's going to be 1 hydrogen, and this is going to be signal number 2. You go with the number of hydrogens in there, you can easily see that signal number 1 is the same intensity as the 3, so these two, they contain the same number of hydrogens, and signal number 2 is half the number of hydrogens of 1 and the 3. Relevant to that also, you're going to see also that 4 has approximately the same intensity as 1 and 3, so it should contain 2 hydrogens in there. So 4, after you do the integration in here, 4 needs to be 2 hydrogens, and that is going to correspond to the CH2. And then you have the last one, which is signal number 5. After you do the integration, you're going to see that this one is going to be 3 hydrogens. Simplicity, then you're going to check how much it is with respect to the splitting pattern of peak number 1. So peak number 1 is going to be a doublet, peak number 2 is going to be a triplet, and peak number 3 is going to be a triplet. So go ahead and write those in the sheet. Now you're going to see that for each one of these structures, there are 2 tables. There's a table at the beginning of the sheet, and for that same structure, there's a table at the end of the sheet. Now the table at the beginning of the sheet is your prediction, and the one at the end is the one that you are going to get from the Beyond Labs NMR graph. So for your prediction, you are going to use the proton NMR table that is posted on ecampus. And with respect to the multiplicity in your prediction, all what you need to do is just read the number of hydrogens for every signal. For example, the ME stands for methyl, and this is a 3 hydrogens in there. Please keep the same numbering of the peaks as the proton NMR in Beyond Labs. Now at the end of the sheet, it will ask you to go ahead and draw both structures in this worksheet, and assign all the peaks in there together with its splitting pattern. Now if there is any calculations, of course, for the integration, please go ahead and include those also here. Take a picture and then upload the files for both structures. This is going to be for the first worksheet. You are going to do the same for the second worksheet in there, and please remember to include every single spectrum in your lab book. So once you go into the qualitative analysis, and once you have your structure in there, make sure you save every single spectrum. This is what you need to do. Just save it, and then the image will show in your lab book. So your lab book should include every proton NMR spectrum for the proton NMR lab.